All right, good afternoon. What we're going to do today is we're going to go over one of the first lectures or first items of notes that we would take in the 2020-2021 school year. And we're going to start with a presentation that I think most of you won't find all that difficult. Some of these items you will already know, except for some of you there might be an item or two that you're going to pick up, and then there might be a little bit of refresher. Okay? All right, so let's get started. I'm going to entitle this particular presentation, it's going to be called Measuring Help. And it's going to be all about measuring. It's going to be about some of the scientific thinking that goes behind measuring and what it takes to get a good measurement. Okay? All right, so I'm starting with this particular very first slide, and you'll see you've got a lot of arrows right in the bullseye, which would be very, very accurate. And then you've got this drag card here, which would go very, very fast. Well, that leads me to my first statement. And the first statement is that I don't care how fast you are if you aren't accurate. And I think we would all agree that there are areas in life where we want people to be very, very accurate. We want a nurse or a doctor or someone who is administering some kind of drug, especially maybe like a shot or something of that nature that calls for a specific volume. We would definitely want the person to be accurate. So there are many, many instances in life where we are not only desirous of accuracy, but we have to have accuracy, okay? And so you need to understand as a learner, and the average person probably doesn't even understand this, but you need to understand that there's a difference between accuracy and precision. Those, a lot of times we think they're the same thing, but they're really not. And so I just kind of pulled out an example out of my own personal life to try to help you a little bit here. And I love archery. I'm an avid archer. And I took 3 pictures here, okay? And you'll be able to, on your Chromebook, you will have these presentations so you can open them up and you can look at them at your own. You know, I'm not going to zoom in and out on some of these lectures, but you'll be able to look at them as much as you want. Here I have my longbow, and I took my longbow and I shot several arrows, and I didn't do too bad. I was fairly accurate. Here's a picture of where we go to the Reinhardt 100 every summer, and this is a big dinosaur, and when you blow that up, you'll see that I hit right in the bullseye. Well, here it is, though. I was pretty accurate, fairly accurate here, but I wasn't all that precise. Here, those of us who shot, we were kind of accurate, but once again, what is precision versus accuracy? Well, we all know that we want to hit in the bullseye. This is precision. I went out one day and I was shooting, and I was aiming right there. So you can see that I didn't hit right in the dot. Now, was I precise? Yes. My arrows kept hitting almost in the same spot, and they were touching. What would that be similar to? It would be similar to me taking a measurement and getting the same measurement several times. Well, that sounds really good, Mr. Day. Yeah, that would be really good if you were accurate. If you were in the bullseye, then that would be good. But what if your measurement wasn't accurate, but yet you were showing precision? Well, that's probably not a bad place to be because we can probably improve upon that. But precision is when you're stacking them in, but accuracy is when you're right on the bullseye. So what do we really want to be in an ideal world? We want to be both accurate and precise. But we need to understand that in chemistry, there's a difference between those two terms. We want to be precise, but we want that precision to be coupled with accuracy. We want to be accurate, and it would be very nice if we could be precise. So we want to do both of those things while realizing that there is just a little bit of difference between those two terms. Okay? All right. When we measure in this classroom, we utilize what's called the metric system. We a lot of times refer to that as SI units. That stands for System International. And in the metric system, there are different types of measurements that we can take. And each one of those types of measurement usually has what's called a base unit, okay? And I always kind of tell my kids, if you think about the base unit, you can kind of go one direction or the other. You know, you can maybe go a little bigger, or maybe you can go a little smaller. And I'll kind of show you what I mean by that here in just a second. And I kind of give you a little bit of a table here, but I'm going to be honest with you, we're not going to pay a lot of attention to that. That was just sort of a, you know, kind of a mention, all right? We're going to look at things like length, volume, mass, weight, time, temperature, energy, and density. These are different types of measurements that we're going to look at. And because they are different types of measurement, they would have their own units. And a unit would be the item that would not be a number, it would be the item that defines the number. And each one of these also, due to their difference, they would have a different base unit, okay? And that is something that we want to talk about in this presentation. All right, but before we go on with that, and we will here in a minute, I want to show you what I'm talking about a little bit. Right here is a number. The question is this a measurement? And the answer is, at this point, no. Okay, this is not an adequate measurement in science. All right, why? Well, I don't know. What is it? Is it 2.5 2x4s from Lowe's? Is it 2.5 gallons of milk? What is it that you want me to know from this number? So what would that number have to have in order to be an acceptable measurement in science? Well, honestly, it would have to have two parts. It would need to have a number, and it would also need to have a unit. Now, this particular unit is the unit for weight. The unit for weight in the metric system is the Newton with a capital N, and that capital N would also be very important, okay? Now, what about this? Once again, well, it's not an answer, Mr. Day. Okay, why is it not an answer? Because it is lacking a description. We don't know what type of measurement it is. All right, so what type of measurement is it? Well, in this particular case, if we supply a little g, that would be a unit. That would be a unit for what? Well, it would be a unit for mass in the metric system. It would be a gram. A gram in the metric system is basically the equivalent of one small paper clip, okay? So, I give you a listing of some of the measurement types that we're going to use in my classroom. Things like length, volume, mass, weight, time, and temperature. I give you some various units because, as I said before, remember, you kind of got the base unit, all right, and the base unit is the one that I have circled. Now, honestly, I'm only going to give you one unit for weight in here if I give you a metric system unit, so I'm not real worried about that. And we're going to use degrees Celsius rather than Kelvin, okay? In this classroom, we'll use degrees Celsius. So what with these others that are circled? Well, they're circled because I want you to also be aware of what the base unit is. So the base unit for length is the meter. The base unit for volume is the liter with a capital L. The base unit for mass is the kilogram, although quite frankly, most of the time in here, we'll probably speak in grams. You know, a lot of times we will talk in fairly small amounts, especially if we're making a solution or something like that. All right. When we talk about time, the base unit is the second. All right, so what do you need to do? Well, you need to familiarize yourself with the type of measurement, and you need to familiarize yourself with some of those units. And in most of your cases, you probably are already somewhat familiar with these metric units. So it's probably not going to be that difficult for you. It's probably going to be more review. All right. What else? Well, what about energy? Well, energy is the joule. Okay, and that may be something that's totally new to you. Okay, you may have never heard that before. So what are you doing in this classroom? You know, hopefully we don't talk about everything you already know. Hopefully we talk about some things that you don't know. Therefore, you're going to add to your body of knowledge. So the base unit for energy is the joule, and density is an interesting measurement type because something happened here that had not happened in the previous 7. The previous 7, you know, you were looking at one unit at a time. Density is literally a value that is derived from a calculation, and it is a combination of two units. It's kilograms over meters cubed. Now, that's probably not the only unit for density. That's just an example. Okay, what do I want you to take from that? Well, I want you to take from that it is possible sometimes to have a unit that would be a combination of units. Now, I'm only asking you in this first unit to learn about these 8. Okay, so yes, it's a little bit of good old-fashioned memorization. That's exactly right. Okay, in this unit, I'm also going to ask you to do some simple math work. Simple math, things like simple division. All right, things like being able to divide one number into another. Our math in this first unit isn't really going to be all that super complicated. However, since you are going to be using tools that have, a lot of times they have what are called graduations, or they have lines, and we'll talk about that in a minute. Since you're going to be using tools that have lines on them, then you need to be able to do some simple math. You need to look at the span, you need to be able to count the number of lines, and you need to be able to do some simple division. It's something that I'm very confident that you can do if you just slow down and think about it. Like, for instance, this is just a total for instance. What if I had a span of 4, okay? But I had, if you count with me, 1, 2, 3, 4 lines. Well, then simple math, I'm going to take my span, I'm going to divide it by my number of lines, which is going to be 4 divided by 4, and so each one of these lines is going to be 1. Now, this is what I would tell Braxton and Tristan Day, my children. This is what I told them back when they took math. If you do a math problem where you can check your work, then you don't have any reason to miss it. You should check your work. So if I believe that each one of these lines is 1, then it's a simple 1, 2, 3, 4. How did I get that? I got that by dividing span by the number of lines. I can use that simple format to solve for any graduated item that has lines on it. Okay? That's just pretty simple stuff. Span divided by the number of lines. Okay? Now, something that you also want to keep in mind. You can divide a larger number into a smaller number. There's no law that says you can't do that. For instance, if you had a span of 1, but you had 10 lines in between, then you would be dividing 1 by 10, and each line would be 0.1 or 1/8. Well, once again, you could go 0.1, 0.2, 0.3, all the way up and count until you get to 1. You could check your work. But that's not the point. The point is you can divide a larger number into a smaller number, but your answer will be in a decimal. So don't be intimidated by something like that. For instance, you can divide 1 by 10 and get 0.1. You can check me with your calculator if you'd like. You can divide 4 by 8 and you're going to get 0.5. It would be the same as dividing 8 into 40, right? You could divide 10 by 20. Well, once again, you're going to get 0.5, because if you think about setting that problem up, it's going to be like dividing 20 into 100, okay? You're going to get a 0.5. What did all three of these share? Well, they were a bigger number divided into a smaller number, but the answer was a decimal, okay? And so don't be intimidated by looking at a scale. It's very easy to calculate a scale. You know, whether you're looking at a beaker or whether you're looking at a meter stick, whatever the case may be, it's not that difficult to figure out. Just a little bit of simple math, okay? One of the things you do want to do when you're using tools, and once again, you know, you can take this on your notes and you can use your screen, you can blow it up, you can look at it. I took a picture here of a ruler, but the ruler didn't start at the end. The ruler started right there on that line. Well, that's already a mistake. It's a simple mistake. It's an easy mistake to make. It's a mistake that's made because we're just not paying attention. So when you use a tool, you just simply have to slow down a little bit. You simply have to pay attention to the tool, okay? You can start anywhere in here that you want. You know, nothing says you have to start right there, but you do have to start on a line, Okay, and I know you think, well, that's not much of a mistake. Well, not much of a mistake. Not much of a mistake might mean the difference between this piston fitting into this cylinder and this piston either being too loose and sloppy or being too big to where it can't fit. There are plenty of examples in life where we need precision and accuracy, and that goes all the way back to the beginning of this discussion. I shouldn't have to sell you on precision and accuracy because no one wants to buy something that doesn't work, okay? All right, so once again, you can start anywhere, particularly if you're using a ruler. You can start anywhere you want to in here. It doesn't make any difference. You don't have to start at a 1 if you can do simple math. If you want to start at 46 and measure to 60, that's okay as long as you can subtract 46 from 60 and get 14. Most people tend to not want to do the math, so they start at the beginning, but you don't have to. Just make sure you start on a line, okay? And once again, I'm not trying to insult your intelligence, just something to think about. The same thing could be said for a Newton scale, which measures weight. All right, so the difference between these two pictures is that this particular scale right now is on 0. This particular scale is on 2. Now, I'm not telling you this is an ideal setup, but what I'm telling you is that if they're both calibrated properly, the fact that this one's off a little bit on the lines doesn't mean you can't measure what you need to measure. It just simply means that you're going to have to do a little bit of math. I really like this one as well because if you blow it up and you look at it with your fingers, here's what you're going to see. You're going to see that the span is 4. But when you count the lines and you don't count the first one, okay, that's where you start. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. So the span is 4, but the number of lines is 8. So how did I tell you to do that before? Take the span divided by the number of lines. So 4 divided by 8, pretty simple stuff, right? That's not very difficult math. It's going to end up being 0.5 once again. Now, how can I check that? Well, it's easy. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. All I have to do is slow down and check myself to make sure that I've done it properly. A lot of mistakes and a lot of measuring mistakes and a lot of mistakes working with tools can be avoided if you'll just slow down and think. Not that difficult, okay? How about measuring volume? Well, some of you have used what's called a graduated cylinder, once again called graduated because of the lines that are on the cylinder. Most of you have used a graduated cylinder, some of you haven't. But when you use a graduated cylinder, you measure from the bottom of this curved line. And this curved line is liquid. You measure from the bottom of the curved line. The bottom of the curved line is called the meniscus. So you don't actually measure from this, what appears to be the high point on the sides. You measure from this curved line called the meniscus. And volume would obviously be the amount of matter that is present, in this case a liquid, and it would have its own unit, and you're committing some of the units to memory. This particular unit would be milliliters, okay? Would be milliliters. All right, what about time? Well, time, in this particular case, and you look at this particular stopwatch, you might have hours, you might have minutes, you might have seconds. Okay, now, most of the time I would doubt that in this classroom you would measure much in hours, but you certainly might measure in minutes or in seconds. And when we take measurements this year, I'm going to teach you more in this unit. I'm going to teach you about significant figures. I'm going to teach you about how many numbers do we use? How do we write our answer? But that's a discussion for a different day. Today's discussion is just about the importance of precision, accuracy, some of the measurement types that we'll look at, some of the units that we will use, and just some fundamental items that we need to keep in mind so that we can be successful when we measure. We want to be precise and accurate. We don't want to just be precise. We don't want to get the wrong answer 5 times. We want to get the right answer 5 times. We want to be precise and accurate, okay? In this classroom, we will always try to use a unit that is appropriate to the measurement that we're taking. So if I'm going on a trip out west, I'm going for this big long drive, the appropriate unit is not going to be meters. Okay, a meter is only about 39 inches long. So what would the appropriate unit for a trip like that be? Well, it would be kilometers. Okay, if I'm going to take a big long trip like this, then I'm going to use the appropriate unit. So part of what you have to think about in this classroom this year, and most of the time it's going to be pretty easy, but if you're taking a measurement that involves a lot of liquid, then it would probably be expressed in liters. But if you're using a measurement that only, something that only requires a small amount of liquid, then the most appropriate unit is going to be milliliters. And I know that you did not grow up using the metric system, but I'm going to be honest with you, that doesn't matter. The metric system is the accepted system of measurement in the scientific community, meaning it is a standardized system of measurement that means the same thing no matter where you're at. That's what a standard is. We use a standardized measurement system so that no matter where you are, when you talk about things, you talk about them in the same way, okay? The metric system is the recognized system of measurement for science. That is what you will use. And that's one of those where it doesn't matter whether we like or dislike, we have a responsibility to learn what is universally accepted, okay? All right, so one more time. What would the measurement on this be? Well, so I intentionally chose one that didn't start at the first line. So I want you at some point to look in your presentation, and I want you to find out, you can take your fingers and make your screen a little bigger. I want you to find out what you think that measurement is. And the reason why I did this is because you cannot be afraid to use a little bit of simple math. All right? And then the last thing that I'm going to point out to you in this first presentation, and it's a shorter presentation. A lot of it is just review. A lot of it is just to get you thinking about measurements. I'm going to run a day's lab. We're going to come in one day and we'll do a lab where I will have all of these different tools out, and you will use those tools to find different measurements, or you'll show me that you know how to read them, or you'll show me that you understand the unit that goes with that tool. And we might have a short presentation just before that, okay? All right, this beaker, once again, you would read from the meniscus. But every year, I have people that make a very fundamental mistake, and it's an honest mistake, but yet it's a mistake because they're not thinking. There are two scales on this beaker. One of them is for filling the beaker up. The other one is for pouring out of the beaker. If you think about this, that makes perfect sense. If I want to pour a certain amount out, then I need a scale that goes down. But if I want to fill it up, then I need a scale that goes up, right? Okay, so common sense says which side do I use depends upon whether I'm filling it up or whether I am pouring it out. So what I want to say is that you won't find it that difficult to do and to use a lot of the simple tools like thermometers. I'm sitting here and I'm thinking, we're going to use thermometers. We might use an old school triple beam balance. We might use a Newton scale. We might use a ruler. We might use a meter stick. We probably will use things to measure volume, whether they be beakers or graduated cylinders or whatever the case may be. But a lot of the tools that we use will not be that difficult. However, they will have graduations. You will have to understand how to calculate the scale. You will have to understand what unit goes with that measurement type. And you will have to understand what unit that tool gives you. Like for instance, this one, once again, gives you milliliters and not liters because it's a smaller amount of volume. All right, I don't think you'll find that very difficult. I think you can watch this if you need to as many times as you need to. You can look through your notes as many times as you need to. But that's your responsibility to begin learning the material. But I will post this and you can look at it as many times as you need to. Take care. Have a good day.